This is just a short video to give you some hints on how to do part 2 of the analysis for your HCl-DCl lab. First of all, I'm not sure why equation 5 is in here twice. It's just a straight up copy, so you could ignore that fact. But let's look at what this is. This is a difference between energy of two states, with the vibrational state changing and the rotational state changing. And so this is basically the location of a peak, right? Because it's a delta E. So location of a peak in your spectrum is equal to, and then you have all of these factors, right? So we have the basic vibrational part, and then a correction, and the basic rotational part, and a correction, and another correction. So we have like anharmonic correction and others. We have three corrections in here. So this gives you what the energy should be for each peak. Now basically then you have an equation where you have y is equal to a function of all of these variables. So you have several unknowns, but you also have several equations because the equation applies to every single peak. So what you have to do is set up an Excel spreadsheet where you have all of the actual experimental peak positions, and then all of these coefficients you know because you're just assigning the quantum numbers for the vibrational state and the rotational state. So those you can calculate in a straightforward way since you've labeled each peak, and then basically you're solving for all of these constants, which are the physical constants then that we can compare to the literature. So you have to put them all into an Excel spreadsheet, and these are the different columns that you'll have. So you need to know your quantum numbers, and you'll get that from your labeled spectrum. You need to know your actual experimental values, and then these are just the coefficients that you calculate from these constants. So by coefficients, we're talking about all of these things in brackets. Those are basically coefficients. They'll be integers for your unknown constants, physical constants that you're trying to solve for. So this is what the spreadsheet ends up looking like, and I just took these values from the data from the Journal of Chemical Education. Your values will be a little different for your actual experimental data. But since you have each peak labeled, you'll put in your different vibrational quantum numbers, your rotational quantum numbers, for the two different branches, so J going up and down, and then you'll have your actual peaks, those positions, and then you have to calculate the coefficient for nu. So for example, that is nu prime plus a half minus nu double prime plus a half. So I just put that equation in here referring to the cells nu double prime and nu prime, and I distributed the negative value, and so on. So then for the BE, you put in the equation that refers to the J prime and the J double prime. For the NUX, it's a negative, so I called it neg nu x and put in the equation, etc. Neg DE depends on J double prime and J prime, and neg AE depends on all four. So we've got the coupling of the vibration and the rotations in this one. Once you have all that in there, then you go to Tools, and you have to put in the add-in, if you don't have it already, for the data analysis, the analysis tool pack. I already have it, so then under data, no, is it under tools? Crap, where is it?